Good afternoon, everyone. How are you doing today?
Thanks.
Nice, nice, nice. Tatiana, can you unmute for me? It's green.
Yes, sir.
You see, when you come class later and you're not your teacher at all, you see, have you asked? I will sir, there, sir, you no work to do? You see what
Sir,
life
that's
is? You
because I
see?
was wondering if I was coming late for you.
Me know. I know you're always here. I'm just pulling your legs. No man, I'm here. I'm just waiting for the others to join. At the time I had only 9 students. I'm now seeing 16 of you, so we are going to begin on. Teachers are pulling leg. All right. So tonight again should be a funnish class. I should be able to finish off with the trigonometry tonight. Um, Somebody's going to say to me, sir, now we're telling a line. I'm going to understand the unit circle so well. Not a problem. I'm going to be spending some quality time reviewing the unit circle, and then we have done. I think there are 4 units in the trigonometry, 4 sections in the trigonometry, and this section is the second one, if I'm mistaken. If I'm not mistaken, 8.2. Is this 8.2 load? Wow, this is 8.1. this is 8.1. Okay, so 8.2 then is going to be solve equations including trigonometric functions. Wow. So I have a few questions here. I'll have to generate some as I go along so we can get enough practice. Um, but I want us to review this thing here. But before, I know what I'm gonna do. I know what I'm gonna do. I'm gonna give you I'm gonna give you a couple minutes. Where my Lord, where my Jesus? I'm gonna give you a couple minutes to review, to do I'm gonna need a couple minutes to look at the unit circles. One in degrees, the one in radians. Foxy, I think, asked a question on Monday. So we can study one, and then we just work up, and for the other, and my answer to her is yes. Right? So take about 10 minutes. Look at it to see if you think you can remember it, find some ways of doing it, and then I will go through with you in another 10 minutes, and then we'll attack some questions. As I said before, I don't have many questions here, and I will definitely generate some questions as I go along. But see if you can do that for me, and then we can just take it from there. I'm right here, so if you have a question and you ask a question, I will hear you because I'm not moving. I'm right here. All right, so I'm going to mute, giving you an opportunity to do some stuff. Now, here what? 17 of you here. I don't want you to think it's time for you to go on TikTok. It's not time for you to go and watch your IG profiles and your Twitter and anything else. It is math time. I'm giving you some work to do. You don't know if I'm going to say, John Mark, tell me what is this? This is a time I'm helping you to study something in class that we're going to be using, all right? So take a few minutes, please, and thanks. All right, how is Steve?
Good, sir.
All right, good.
Okay.
All right, so is there anyone in the class that has a difficulty with this? Because if no, instead of me having to go through this, I will just move into some work examples now so we can better utilize the unit circles. Are we okay with this so far?
Sir.
Sir, I
Mhm.
want to ask a question. We have to know the thing around the 1 0 something around the circle as well.
Then, mom, how you gonna find the angles? How you gonna know what is sine of 30? The sine of 30 is a half. So this gives you the answers, you know. So the sine of 30 is going to be a half. The cosine of 30 is going to be root 3 over 2. So I'm giving you this so that it becomes a quicker method for you to do your evaluation than for you to sit down and depend on a calculator to do all of them somewhere. So you can actually say, for example, a multiple choice test. You can move through the multiple choice much quicker and save some time, you know, to do your revision. All right. Um, Casey, let us do the questions and you see and you tell me whether or not it's useful. I think that's a better answer. Let me start the
Sir,
question. Yes, Tantan.
sir, below the x-axis, the cosine and sine are in the same order.
Yeah, man, it's always cosine sine. It's
Okay.
always cosine comma sine every time. Yeah, so just remember that, guys. It's always every single time. It's always cosine comma sine. Remember, the cosine is reference to the which axis? Cosine is to which axis? It's the
X.
x-axis. Right,
X,
very good. The x-axis and sine is
fourth
to the
quadrant.
y-axis. Right. So look at what happened. So remember what I demonstrated to you last class? When I draw my line right here, so this is going to be halfway. Because from the from the center to here is 1. As a matter of fact, the radius is 1. Anywhere along this is 1. That's why it's called a unit. Unit is 1. That's what it means. I think I was asking the question last time and I didn't get a response. But unit is 1. So anywhere along from the center to the circumference of the circle is 1 unit or 1 radian. All right? So when I draw a line from here, sorry, let me just annotate later. When I draw a line from here all the way here, it's going to get to a half. So my y-axis is referencing my sine. So this is where the half come from because it comes here. And when I'm reference here to here, this is going to be 0.7. 0.7 out of this 1. And that's why this is root 2 over 2 because root 2 over 2 is 0.7. And this one here is going to be 0.866. So when I draw that here, it's going to be closer to the 1. So if you recognize, all of these here will be closer to the 1. It's increasing to the 1. So this is 0. They will jump to a half. They will jump to 0.7. They will jump to 0.8. And they will move to 1. So moving from 0 to 1. I don't know if anybody saw that relationship. Let us look at our y-axis. We're moving from 0 to a half, which is 0.5, to 0.7, to 0.8, and then 1. Then, sir, what about 0.9? You know, we're not really interested in a 70-degree angle and 80-degree angle. Because if we get them angle, let us jump on a calculator. We're just interested in the 30, 45, 60. And then multiples of those as we go around the 360-degree revolution. So we move from 0 to a half, to 1 half, to root 2 over 2, to root 3 over 2, to 1. And then from here now, remember now, we're going from this side now, you know. But this 120 will have the same reference y-axis as the 60. Talk truth. Because it's the same y-axis that we're talking about, don't it?
Yes, sir.
Yeah, man. So if you look at it, the reference of this 30 degrees to right here, so to get a half, will be the same reference to the 150. Will be the same reference to the 150. So that's why all these y values are the same y values as here. Are the same y values as here. Because when I'm referencing root 2 over 2 to 45 here to be the 0.7, it is also in the same line as this 135.
So
So
sir,
that's
negative 1.5 I could still be the cosine. The
absolutely, absolutely. Because look at what I was going there, Casey. Watch me. I was going there, and I'm saying to you that it's going to be cosine comma sine. But remember, C A S T. Cosine is negative in this quadrant. Then, sir, so why the two of them positive here? So because this is A. A means all. C is cosine. A means all. S means sine. T means tangent. So the reason all of here is positive is because we are in the all bracket. All bracket means everything positive. All the angles are positive. But using these same angles, when we come over to this side, C, A, S, only sine alone is positive. That's why we have the sine values here positive. Then sir, why positive again? Because it is in the same quadrant as this sine over here. So it has to be positive. Oh, so you're saying that not quadrant, but semicircle. Sorry. It's in the same semicircle, different quadrants, but the same semicircle. And because it's in the same semicircle, it is making the same reference to the positive y. So that's why this root 3 over 2 is the same as this root 3 over 2, because this is referencing to this y-axis, but this value here, 120, is also referring to the same y-axis. This 135 is referenced as root 2 over 2 for the y-axis, same value as this 45, the root 2 over 2. And this 150 is referenced in a half, which is the same as this 30. So remember, sine is going to be positive here, but guess what? Cosine is negative. That's why you have all the cosine values over here being negative. That's why all these values over here are negative, because they are cosine. But sir, I see something here. 1, then root 3 over 2, then root over 2, then a half. Negative 1, negative root over 2, negative 2 root 2. Then sir, you said to me then, sir, since you go through and demonstrate this piece with us last class, if me know this piece, sir, me no can know that piece over here, sir, because me just write by the same thing and just put cosine as negative. Duh. That's all I'm saying. Anybody saw that? Talk to me. Unmute and talk to me as we discuss the unit, sir.
Yes,
Yes,
sir.
sir.
Yeah, man, at the same thing. Yeah, man. Yeah. We could flip down the bottom part here, so now, under the x-axis. You know, so under the x-axis, you know, so we talk about negative values. So it tells me now that I'm going to have a negative 1. Sir, how you know it's negative 1? Oh, sir, because this is a y value. Yes. So x is still 0, but instead of positive 1, now you have negative 1. Okay, let me just get rid of that thing that just hate these notifications. Jesus. So look at what happens now. Sir. So you're saying to me then that the cosine, that the unit circle is only talking about 0, 1, a half, root 3 over 2, and root 2 over 2, sir? Then 1, 2, 3, 4, 5, something there, sir. And then now you have the negative and the positive to them. That's all I've been saying. Yes. Okay, sir. All right. Do the other part now. Let me see. What I'm saying to you is that before I even show you the significance of it, well, let me talk about it. We know that our thing is cosine, comma sine. We know that our thing is cosine, comma sine. Cosine references the x-axis. Sine references the y-axis. Watch me. 210 is going to be the same thing as 320 in terms of my y-axis. See here, when I draw this value across here, so and come across my y-axis, that's why this is a negative a half, and this is also negative a half. That's why they have the same value, because they're referencing the same axis. All right. This 225 is referencing the same axis as 315. That's why I suppose them is negative root 2 over 2. And this 240 is referencing this 300. That's why it is the same negative root 3 over 2 and negative root 3 over 2. All right. C A S T. This is tangent. There is no tangent in sine and cos unless you divide one by the other. So it means that the two of them are negative. That means that this negative, this negative, this negative. But watch me. The only two that goes together is root 2 over 2 and root 2 over 2. So if this is negative a half, you're not going to have negative a half here. We have negative root 3 over 2. And if this is root 3 over 2, so what point I'm making is root 3 over 2 and a half are related. Root 3 over 2 and a half are related. So you'll see combinations of root 3 over 2 and a half. So in this case, you have root 3 over 2 comma a half, but in this case, it's a half comma root 3 over 2. Negative a half, root positive. Well, let me not even use the negative because we know how the negative come in. I'll just show you a half root 3 over 2, root 3 over 2 a half, root 3 over 2 a half root 3 over 2, a half root 3 over 2, root 3 over 2 a half. So the root 3 over 2 and a half are married, but there are different times they take different roles in the marriage, right? Daddy is a provider, mommy is a homemaker. But sir, you're bright. Look how much woman I go to school now and the man them now in a class. Look how much woman in other classes, sir. Why not say the husband a homemaker? Okay, fine. The husband is a mechanic and the wife is a medical doctor. But sir, you're out order, sir, after medicine more. So okay, fine, the two are medical doctor. The point I'm making is both of you take different roles. And even in a marriage, you may say, okay, I am going to, the wife may say, I am going to provide food because I believe my responsibility is to provide food. The husband may say, my responsibility is to make sure I pay the bills, to make sure my family comfortable. So we are going to have different roles. The husband may say, I'm going to take up the garbage bin. The wife may say, I may mop it. On, yeah, I'll soon come take out the garbage, right? And then sometimes, no, this is what is happening. So you have to look at the signs. So they take different roles. Guess what? The one that decides, say, no, we're going to pay half and half. Let me see who make you in trouble. This sound like Shanti, you know. Shanti, will say, no, bossy. You think, say, me, I'm going to pay no bills for you? Negative. So we're going to split it half and half. So that's why the 1 year are the same thing, root 3 over 2 and root 2 over 2, root 3 over 2. So should pay 2 bills this month, he might go pay 1 next month, so forth and so on. The point I'm making is the root 3 over 2 and a half are married. They always pair together, but they come in different portions. One of the things I'm going to say to you is that you know that the sine of 30 degrees is going to be a half. So you know that the cosine of 30 degrees is going to be root 3 over 2. And multiple of 30 is going to be 60. And that 60 is going to be something different. So the sine of 60 degrees is going to be root 3 over 2. And the cosine of 60 is going to be a half. So this piece here switches around to this piece here. So if you can study it like that, the sine of 30 degrees is going to be equal to a half. The cosine of 30 degrees is going to be root 3 over 2. Remember, it is cosine comma sine. Cosine is referenced in the x-axis and sine is referenced in the y-axis. And think about it. In multiples of 30, the sine of 60 degrees has to now be root 3 over 2. And the cosine of 60 degrees is going to be a half. So if you look at multiples of 30, and I'm giving another way of remembering the unit circle. If you look at multiples of 30, you will have your sine. Just remember, the sine of 30 degrees is equal to a half. The cosine of 30 degrees has to be root 3 over 2. Because root 3 over 2 is married to 1/2, one will go with the other. All right? So when you look at multiples of 30, it means then that the sine of 60 degrees has to now be root 3 over 2. It cannot be a half. It has to now be root 3 over 2. But therefore, now the cosine of 60 degrees is going to be equal to 1/2. And remember, 45 is when the husband and the wife decide, say, here's the plan. Me I buy one bread, me I put half how much for the bread, and you put the other half as much for the bread. Them not spend more than each other. All right? So that's why the 45 degree is going to be the root 2 over 2 and the root 2 over 2. It is the same angle. Now look at me. Look at the unit circle. Anything that ends with a 5 has root 2 over 2. Talk truth. Tell me if anybody recognizes that.
Yes, sir.
Yes, sir.
Very good. So anything all right, so anything that ends with a 5, best believe that it's going to be root 2 over 2, root 2 over 2. But with sine it is now is going to be the challenge. You will need to know where it is. I'm only telling you the combinations. All right. So anything that ends with a 5, 45, whether sine or cos, is going to be root 2 over 2. Then we have 135, 225, 315, root 2 over 2, root 2 over 2. You now need to know which is which. And then one of the things you can use to know is that CAST. So in A, you're going to have the 45. In A, everything is positive. So that means 45 is going to be root 2 over 2, comma root 2 over 2. Then after 45, you're going to have 135. 135 is going to be in the second quadrant, and the second quadrant only cosine, sorry, only sine is positive. Only sine is positive. That means the other angle is going to be negative root over 2 and root over 2. And then no, 225 is going to be in the third quadrant. In the third quadrant, only tangent alone is positive. That means we have negative root over 2 and negative root over 2. And in the fourth quadrant, now we have 315. 315 only cosine alone is positive. So that means we have positive root over 2 and negative root over 2. Tell me if that makes sense.
Yes, sir.
Yeah, man. So
Yes,
just
sir.
go through the unit circle and you should be fine. Just go and look at different things. You know, when I go to school, I wish my teacher they spend time on some here. Maybe I'll be better off, you know. Oh, sir, I don't
But
know.
sir, you're teaching math, so you're already better off.
Tantan, leave me alone and go drink a cup of hot chocolate tea. Yeah, don't worry about it, don't worry about it. Guess what? One of these days, Tantan, you will get to the stage. Let me just speak something into your lives. I will speak something into your lives. I know quite a number of you here in this class want to become a medical doctor. And I'm going to say to you, I'm going to encourage you. And some of you are on your way, you know, into getting into medicine. I'm going to encourage you to do it. I really am going to encourage. And you don't have to be in medicine. I don't know. Some of you may want to get into law. Some of you may want to get into engineering. You know, you have your eyes set on something. But you see, if it don't work out for that one, quickly readjust. Quickly readjust to find something else that can possibly work out for you. Just think about something else that could possibly work out for you, because trust me, I don't want to tell you what I wanted to have studied, and you couldn't tell me when you wrote that it was going to be anything other than that. Kill me dead, that's what I was going to do. But more and more when I went to the university, I recognized that I used to go to class, and then after that, my friends used to say, you understand what I'm going? And I found myself teaching my friends the things that I learned. And in teaching, I recognized the information was concretized in my head. So I never had a problem with it, because the more I teach is the more I understood the concept. And then I said to myself, but, so hold on there, a teacher never taught? He said, the blood is against it. He said, I don't want to teach. And then I went into teaching for what I thought would have been 2 years. And I don't want to tell you how many years later this is. So I'm saying to you, Tantan, yeah. I said this to say to you, based on what you said to me just now, that it is good that you understand this now that you're in college. Because some of you may swear, say, they will turn this big, grandiose engineer. But guess what? You may end up teaching physics and maths. Maybe not for a lifetime, like sir, a teacher for a lifetime, you know. And trust me, the number of years that I've been teaching is a lifetime for many people. All right? But I'm saying, just understand and appreciate, because you don't know where this life will take you. Some of you will end up becoming bank managers. Me now ask you, what sort of science is marine? And so you may get your first class honors in chemistry or bio, and you may just find yourself into the banking system to work and love it and decide to go to an MBA. Bam, bank manager. When you become bank manager, you must remember me here. All right, move on. So just try and understand it. So I've gone through some of those stuff, and there are many other little things that you can look at. As I said before, just remember, a half, comma root 3 over 2 are married. You know, in the first quadrant, everything is positive. In the second quadrant, only sine is positive. Third quadrant, tangent is negative. So because you're in the third quadrant, I'm only talking about sine and cosine. Everything there is supposed to be negative. So you can explain these negative signs.
Sorry, I mean tangent is positive.
In the third quadrant, tangent is negative.
So how cosine and sine negative as well. So everything is negative?
Tangent alone is positive. Somebody say, tangent alone is positive. That means everything else is going to be negative.
Sorry, I said tangent is negative.
I said that to see if you were listening, Tantan, and thank you that you were listening. Forgive me here. So tangent is positive. C-A-S-T, tangent alone is positive. That means everything else is going to be negative. All right. Let me move into the question. Because it will move a little closer. Thanks again, Tantan. It will move a little closer to the understanding. Sorry. Cassie, unmute for me, please. Or you feel now? Feel a little better now understanding this unit circle?
Yes, sir.
All right, make sure that is a true yes at the end understand me yes because you want to say yes, you know. All right.
Understand, sir.
All right, very nice on the bunches. All right. I don't want anybody to blink just yet. Don't blink. We're going to work through this example. It says solve for x in the equation. G's and P's, solve for x in the equation. You know, 2 sine x supposed to equals to 1. You must solve for x. Oh, they might ask you to find the value of x. What hold on now? So x is themselves greater than 0, but less than 2 pi. Wow. X is greater than 0, but less than 2 pi. All right, guess what? We're not going to freak out, you know. We're going to work like how we normally do maths, because maths is, we have some procedures in mathematics that carry us right through from the grave, from the cradle to the grave. Watch me. I want to find the value of x. That means everything else that not have x, maybe get rid of it and fling over to the other side. With that said, I have 2 sine x. I don't want the 2 because x I don't want. So what I'm going to do is divide both sides by 2. Then, sir, why divide both sides by 2? Oh, because the 2 is being multiplied by the sine x to give you 2 sine x. And the opposite of multiplication is division. So therefore, I'm going to divide both sides by sine x by 2. So I'm going to have 2 sine x over 2 is equals to 1 over 2. So I'm now going to be having sine of x is equals to a half. Okay, so let me see that illustrated, but where will go from there? All right, thank you for asking. So if I, sir, you know, say like when we do what the topic called again, sir? Matrices. And we want to get rid of something, we multiply by the inverse or something, sir. Because when we multiply something by its inverse, we get rid of it. What true you're talking about? So that means if I multiply sine by its inverse, sine inverse times sine is 1. Oh, so sir, that's how you're going to get the x alone on the left-hand side. But sir, when you do that, sir, what's your way to do to one side of an equation, you have to be to the other side. Very good. That means so you have to multiply the right-hand side to by sine inverse. Yes. Oh, so what we're going to have now, sir, is x is equals to sine inverse of a half. Very good. Class, do me a favor. Go ahead for me and find sine inverse of a half and tell me what it is that you get.
Or 30.
30 yams, bananas, pumpkins. 30 what?
30 degrees.
30 degrees. All right, good. 30 degrees. That is only piece of the answer, you know, because they never say 0 and 360 degrees. Then says 2 pi. So no. 30 degrees. 30 degrees. 30 degrees, right? So. But what do you know, sir? This and this give me no. Sure, that's not right. Do me a favor, guys. Find find sine of 150 degrees and tell me to get this because you don't understand this.
0.5 a half.
A half, done. Oh, listen. So that means a half. That means that 30 and 150 are the only two angles in here. So for sine, that will give me positive a half. So that means if when we define the inverse of negative 1/2 and we get 30 degrees, that means the inverse of that is supposed to be that. So that means a 150 degrees. Sir, me now follow yet. All right, let us go to the solution now. So you see what Sir has? 2 sine x is equal to half. I mean, is equal to 1. I'm dividing both sides by 2. From here, look at the unit circle to determine an angle in radians. You can look at sine of x to be equal to a half. This is sine. So we look at the units. Oh dear. We look at the unit circle to see which of them will be a half. Recognize that it's 30 degrees. All right, hold on. Press pause. So when you find the inverse of sine, we can get that. Then, sir, or you get pi by 6. You don't understand. You know, so that's 30 degrees. Answer is in 2 pi. The answer is in pi. So I'm saying to you, you now need to be able to convert these angles inside here very quickly to pi. Because the angles on the outside here, the values on the outside here, are the same values on the outside here. The only difference with the unit circle in degrees and radians is that this has degrees inside of the middle, and the one you have radians inside of the middle. And sir, show you quickly how it is that you can get the something. Anybody remember what sir said to you?
So remember what you said about what?
So for what?
What is 180 divided by 30? Talk to me now. What is 180 divided by 30?
6.
What is 180 divided by 45?
4.
What is 180 divided by 3? Sorry, divided by 60. Sorry.
3.
3.
Watch me. 180 divided by 6 is 30. So this is a 30 degree. 180 divided by 4 is 45. 180 divided by 3 is 60. So sir, show you how you can quickly convert from your degrees into your radians. So the 30 degrees is going to relate to pi by 6. That's why sir had this pi by 6 right here. I can't leave my answers in the green because the question did say between 0, x lies between 0 and 2 pi. So what does that mean? X lies between this point here, come right around into a complete revolution. A complete revolution, sorry, let me use the other one. A complete revolution is going to be 2 pi. A complete revolution is 2 pi. Incidentally, this is going to be 1 pi, and it come back around this time, 2 pi. So we have 0 right here, so you can also have 2 pi. Complete revolution is 2 pi. All right? But sir, all right, let's see where you get the pi by 6. This 5 pi by 6 now, sir, where you get? What is 5 pi by 6, sir? Multiply 180 by 5 divided by 6. Quick time. 180 by 5, 180 divided by 5 divided by 6.
150.
Very good. 150. Remember what sir says? This half, pi by 6, has a reference angle here as 1/2, positive 1/2. But that's not the only angle that has positive 1/2. There's another angle that has positive 1/2 as a reference angle. I'm going to be 5 pi by 6, which is 150 degrees. So That is that's the solution for this question. That's the solution to that question. What I'm saying to you here now is, please note, what if the question had said, what if the question had said, find all solutions for the equation that it not tell us between 0 and 360. Yeah, sorry, 0 and 2 pi. It just said find all the solutions. Find all the solutions. Every single one of the solutions will exist. Every one of them, so all infinity. That's what we're talking about. So when you hear them say all solutions, it's every single bit of possible answer you can get. Remember, you can go around the revolution many times, 1, 2, 3, 10, 20, 30, 50, 100,000. Look at what will happen. This pi by 6 is the same pi by 6 plus 2r, 2 pi n. N is an integer, and n is going to tell me how many times of the revolution that I'm going around. So if I'm going around one revolution, it's going to be 2 pi. If I go around 2, that, and see the same pi by 6. Pi by 6 plus 2 pi n. This is just telling me how many times I go around. In this case, I did not go around one complete revolution. So n is not even 1. N is an integer, so n can be half. All right. So in this case, because I never go around to a complete revolution, this is 0, because it has to be a whole number. So that's going to have pi by 6, which is this pi by 6 here. And of course, same difference here, so that's going to have pi by 6. That. So the only two possible solutions to this question here, 2 sine x is equal to half, between 0 and 2 pi is going to be pi by 6 and 5 pi by 6. Sometimes the question can ask you to leave your answer in degrees. And Cassie, that's why I said to you that let us look at the unit circle in both degrees and in radians. All right. I could find copies of a unit circle where it is both in degrees and radians, but no, if you can look at the unit circle right here, so, and it looks so clustered already, imagine if me go put the degrees right here, so you can say, sir, go with that. So it is best for me to just separate it, talk about that, and show you how quickly you can convert this. Quick time. You know, spend more than, you're going to spend like about 5 seconds to convert. What is 30 degrees, sir? 30 degrees, you just convert it. Just quick time. You know the formulas. That's why I started giving the formulas. All right. Sir, what is 5 pi by 3? What is 5 times 180 divided by 3? Or you can say 180 divided by 3 is going to be equal to 60. And 6 times 30. So that means this is going to be 300. What is 3 pi by 2? Pi divided by 180 divided by 2 is 90. 9 times 3 is 27. This is 270. 4 pi by 3. 180 divided by 3 is going to be equal to 60. 6 times 4 is 24. This is 240. What is 3 pi by 4? 180 divided by 4 is going to be equals to one of them number there, 45. Thereabout. I multiply by that, you can get 135. All right? 135 times 45 is 135. Right? So you have to play around with it in order to get so very comfortable, so that you can just reel off the angles in quick time. All right, so do you all understand this one example that we looked at so far?
Yes, sir.
Yes, sir.
Okay, good. Is there
Kinda.
a kind of, okay, and I love Tantan your honesty, because I was going to ask you, is there another student in the class that don't have a clue what to talk about or kind of understand? Kind of understand. All right, no problem. Anybody else? There's only 2 students sitting, that means everybody else understand.
Yes, sir.
You too?
Yes, sir.
All right, cool. Let's go to this question. And I want you to work with me. No, the question says,
Sir?
Yes, please.
Sir, before I go to the question, can I see the circle again, please?
Can I do what?
The circle with the radians. Yeah, that one.
What do you want me to do with it?
No, sir, just looking for the 30
Oh,
and
oh,
the
oh, oh, okay,
150.
okay, 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 good, good.
Okay. Okay, sir. Thank
All right,
you.
cool. No problem. All right. For those of you who kinda get it, I am moving on. Don't think that I don't know. Don't, you never hear me that I didn't hear you when I said that you kinda get it, you know. Me hear you. But I want you to look at it at a different lens, different viewpoint. And then you can tell me whether or not you get this one. All right, let's go. John Mark, unmute, Papa.
Yes, sir.
You understand?
How was that?
Do you understand?
Somewhat, sir. I'm kind of understanding.
So, all right, you can mute. All right. Students, I'm gonna say one something. I won't be able every class time to call out individual ones of you to find out if you're understanding. So you may ask a question if you don't understand. In Jesus' name, unmute and answer me. Because if I'm hearing the ones who say, yes, sir, we're understanding, I'm going to move on. Because I stop and I ask. I can't every time stop and ask the whole class. You're understanding, you're understanding, you're understanding, one by one. Just unmute now. There are 3 students in the class who just told me that they're kind of understanding. Now there's a 4th one. Let me know. All right. Let me go over number 1. Solve for x in the equation 2 sine x is equals to 1, where x is greater than 0 but less than 2 pi. So x lies between 0 and 2 pi. Question is, 2 sine x is equals to 1. 2 sine x is equals to 1. I am trying to isolate the value x. I am trying to isolate the value x. Now, the first thing to isolate would be this 2. The 2 is being multiplied by the sine x. The opposite of multiplication is division. So I'm going to divide both sides by 2. So that's why I get rid of this 2, and the 2 magically appears under it. Yeah, it's not really magic. You're dividing both sides by 2. So this 1, and then we put the 2 under there. So now I have sine x is equal to 1/2. I cannot just interfere with this sign and say, okay, sir, divide both sides by sine x. That don't work like that. In order for me to get rid of this sine x, in order to leave x alone on one side, I will now have to multiply by the inverse of sine. I will now need to multiply by the inverse of sine. Same now 2 minutes is that you're doing matrices. You can't divide in matrices. What you have to do in order to find the inverse, you have to multiply by the inverse of the matrix. In order to get rid of it, you have to multiply by the inverse of the matrix. In order to get rid of these trigonometric ratios, you have to multiply by the inverse of the matrix. You have to multiply by the inverse of the matrix. And multiply by the inverse of the matrix, it means that I'm going to be multiplying by the inverse of sine. Then, sir, how you know that the sine inverse times sine is going to be 1? Because when you're multiplying and the bases are the same, you add your powers. This sine x is to the first base, and sine x that I'm multiplying beside it is going to get to the -1 base. And when I add -1 to +1, I'm going to get 0. But anything raised to the power 0, I'm going to get sine to the 0. Anything raised to the power 0 is 1. All sine, yeah man, anything raised to the power 0 is 1. So what I'm going to have now is, sine raised to the 0 times x. And sine raised to the 0 is 1. Sine raised to the 0 is 1. And then I'm going to have x is equal to sine inverse of 1/2. I'm going to have that sine inverse of 1/2. And sine inverse of 1/2 is going to be equal to 30 degrees. Your calculators will work it out in degrees incidentally, so you know how to convert that into radians. That's the point I'm making. So your calculators will be able to work out into degrees. Then, sir, can I write degrees on the exam paper and then convert it into radians? Absolutely. Absolutely. When fixing marks on the paper, they will say if you see 30 degrees, award 1 mark. But if you see pi by 6, award 2 marks. So it means that they will penalize you for 1 mark if you don't convert it. So that's how CXC marks. So they will say to you, if you see 30 degrees, give them 1 mark because that question carries 2 marks. So they will say to you, if you say 30 degrees, give them 1 mark. But if you say pi by 6, give them 2 marks. If you see 150 degrees, give them 1 mark. But if you see 5 pi by 6, give them 2 marks. That's how CXC marks, right? So write down your 30 degrees because at least you know you get 1 mark out of the 2. It's better you get 1 mark out of 2 than you get 0 out of 2. So write it down and then convert it to get your pi by 6 and your 5 pi by 6. All right? So that's all we do. And on the calculator, in order to evaluate this on the calculator, you press the inverse function, then sine, then you should see this function come up, sine to the -1. And then you press your 1/2. And then, you know, you may have to use parentheses for some calculators. You open a parenthesis, you say 1 divided by 2, close the parenthesis equal, you get your 30 degrees. All right, and then you convert your degrees into radians. And then you can get your pi by 6 or 5 pi by 6. All right. Now, question. For those of you who kind of saw it, the second time around, was it a little bit better or it's still kind of for you? Talk to me. And yes, and please feel free
Sir,
to
I
tell me.
actually understand it more now.
Yeah, great. I'm happy. You too? Okay. Great. And you know, that's number one, talk to me because I will go through the stuff. Nice. I'm happy. All right, let's go. Let's go through this one now. Find all the answers that satisfy cosine x. Sir, me know what to do. Tell me somebody what to do. What's the first step that I'll take for this one? I am going to what?
Isolate.
Find do the inverse of cos.
You're going to multiply both sides by the inverse of
Inverse of
cosine.
cosine.
Very, very good. Very good. Right? So I did this one in short. Let me just put method 1, method 2. METHOD method 1. DETER. MULTIP. Multiply both sides by the inverse, by cosine inverse, by the inverse of cosine, by the INVERS, inverse of cosine, SINE. All right. So when we do that, copy. And these questions will come on your paper for like about 5 marks. Yes, so it's not nothing too grandiose. So copy is cosine x. Now, I want you to agree with me. When you're doing matrices and you're finding the inverse of the matrix, there is a particular way you do the multiplication. Talk truth. You have to multiply in front of, don't it?
Yes,
All right.
sir.
Right. It's the same thing right here. So look here. Cosine inverse in front, multiply by cosine in. We can't put the cosine at the back. Can't. I'm going to put a cosine inverse right here. So this one here, this cosine here, is being raised to the first power. So this cosine to the -1 times cosine to the first power is going to be cosine to the 0. And anything raised to the power 0 is 1. So what I'm going to have, copy, what I'm going to have is, and I want to show you this now because afterwards, what I'm doing right here, so no need to do this. I am confident that you are going to be able to just move from one stage to the next, which is why here is going to be my method 2. METHOD method 2. All right. Now, So I'm going to find cosine inverse of negative root 2 over 2. Somebody do that for me, please.
180.
180 degrees. All right, let me just put a little space right here. So. Check that again for me, please.
Sir, my calculator say 135.
Adapt one, adapt my one set too. Check again for me, please.
135.
135, yeah, man, 135, man. All right, so check again for me, please. You can get 135. No. You're gonna get 135. Wow. But when you get 135, let us look. What them answers are fine. Cosine don't.
Yes, sir.
135 is going to be right here, so talk truth.
Yes, sir.
All right, good. So 130. So can you agree why I have the 3 pi by 4 right here, so? As one of my answers down here, you see the answer down here, so I have 3 pi by 4 right here, so?
Yes, sir.
All right, yes. So I'm just going to show you right here, so please. We're just going to do that. All right. Now, we're talking about cosine, right? So look at what happened now. Cosine makes reference to the x-axis. So right here, so in the middle right here, so when we draw it, must connect to the in the middle right here, so talk truth.
Yes, sir.
So the other angle that will give me the same value as negative root 2 over 2 will be this value here, because this value has a reference value here, so does this one. And see here, negative root over 2. And these are the only two in the table that has negative root over 2. Sir, do that again. No problem. I got my 135. My 135 is here. But cosine makes reference to the x-axis. So it means that when I draw that reference angle to the x-axis and extend it, it coincides with this 5 pi by 4. And when I look at this, this is also negative root over 2. Sir, why look at this one and this one? Because it's cosine. Cosine is written first. See here, so? Cosine is written first and sine is written after. So I'm going to look at that. And when I look at this, I'm going to have negative root over 2. But when I go back to the 135, I also have negative root over 2. All right? So that's how I am going to say for my method 1, when I do that, I'm going to get x equals, copy, paste. I'm going to get x equals 30 degrees. And I'm going to show you something here. I don't want you to blink. Don't blink. X is equals to 30 degrees. All right? Now, it did say cosine is equals to negative root over 2. Cosine negative root over 2. And when I did this, I got x to be equals to 30 degrees. Tell me where again, which quadrant again, cosine is going to be negative. Cosine is negative in 2 quadrants. Which quadrant again is cosine going to be negative?
Quadrant 2.
Quadrant 3 and 2 and 3.
Very good. So cosine is going to be negative in quadrants 2 and 3. This is going to be quadrant 2. When 135. What is wrong with me? Am I writing 35? This is 135 here, guys. I don't know why I'm
Still
writing.
not getting. Sarah wasn't getting. I'm not going to say 135.
All right. It means that your calculator is not in degrees. Check the setting on your calculator. I was supposed to say it from earlier, but I forgot. Check your setting on your calculator.
Yes, it is in degrees.
It's in degrees.
Yeah.
Turn it on and off for me, please. And then go again and press second function cosine, open your parentheses, negative root 2 over 2, close the parentheses and tell me what you get now.
Sir, repeat that.
Second function, cosine, then open your parentheses, then you're going to press negative the root of 2 divided by 2 and close the parentheses.
Still getting 180. I don't know why.
What calculator are you using on?
Casio.
What brand? What model? Sorry.
The FX82MS.
Okay, but that should work.
Wait, Tanya, like clicking the divide button, not the fraction divide. Like
No, the ABC. So.
No.
no, you
because
shouldn't be clicking that.
don't click that. It's because you have a negative sign right there, so that's why. Because the divide button is going to give you a different value. All right, so go again. Okay, yeah, go ahead again and press the division button itself this time.
Okay, sir, I'm getting it. Thank you.
Magic, yeah, man. All right. Now, I thought I had said that also. No, let me just pause right here. This is a teachable moment. For those of you who don't have your calculators and you may be using a cell phone or a tablet or a computer to do the calculation, I'm going to ask that you don't do that. You must get your calculators and get your calculators now. I'm sure Tanya.
Sir, can you please repeat the procedure that you just tell her all over, please?
I'm coming to you. All right, because it's important that you understand the algorithm of your calculator. Because you may have the correct working out on paper, you know, but when you put in something on the calculator, you get wrong answer, and it will make you lose a mark or two or several marks. So when you think you come out with 100%, you actually come out with 90. You understand? So get your calculators and understand the algorithm of the calculator from in class. When you go into the exam, it is seamless. So what you're going to be doing, ensure your calculator is in degrees. Then what you're going to be doing next is to press your second function, your inverse button, and cosine. Then you're going to open your parentheses. Then you're going to press negative the root of 2, not the ABC button as Sir told you before in other algorithms, but you're going to press the division sign now. And then divide it by 2, close the parentheses, and you should get your 135. Tell me if that's what it did, if it was that.
Yes, sir, I got it, sir.
All right. Now let me just explain what the calculator is reading. And I want you to try this for me, just to make sure that you know the difference. You don't have to try it, but just for you to know the difference. When you press the ABC button, in this case, because you have a root of 2, when you press the ABC button, it is actually dividing under the square root sign the 2 over the 2. So what it is that you have in the calculator is a negative, the root of 2 divided by 2, but that division 2 is not dividing the whole negative root 2, it's dividing the 2 under the square root sign. So technically you're having the root of negative 1. So put in your calculator for me now and find cosine inverse of negative 1 and tell me what you get. And that's what Tanya was getting, because her calculator was reading it as the negative, the root of 2 over 2. The root of 2 and the 2 is under the 2, under the parentheses, as opposed to dividing the whole thing by 2. So you have to be very careful. All right, Casey, you get that?
Yes, sir.
All right, Natty B, can you unmute for me, please?
Sir?
Or you come to class and don't talk to me?
Sir, because I get little way access to files. So.
You getting what I'm saying so far?
For the most part, yeah.
I got so nice. Hey, I got so nice. Hey. I love it. But you must call the teacher still, do you hear? No one hear your voice. I want to hear.
I aspire to be like Natalia.
Okay, so you aspire to be like Natalia. So it suggests to me that you're playing stocky. Something is not clear for you. Come, Tantan, talk to teacher. What is it that is not clear? Talk to me now. Not talking to me? All right. Remember, no, you know, guys, in as much as I want to move on, it is not going to suit me well to move on and know that the class don't understand. So I will spend the time just to get you to understand the concept. So if you don't talk to me and make me know what is in your headspace, never have a challenge. You know, say, in the face-to-face class, when I move on to most about 5 examples already, because you'll be able to see me, I'm seeing you, I can tell you, say, okay, you know, understand, come on, my desk, come talk to me. That's what I teach, you know. Every time I teach me, look up on the board and write 2 things on the board, man, and say, all right, you know that? Those who are understanding, move on. Those who are not understanding, you know, drown the chair and come sit down around me. But I can't do that in the online medium. So that's why I went start talking and say, talk to me, you're understanding? One of the most answer teacher. Ouch. So teacher can know what I want. All right.
Sir?
Guys, yes, honey.
Sir, for this, you calculated 135 degrees to radians.
You're converting 135 to 3 pi by 4, yeah.
And then when you look on the circle, you see what 3 pi by 4.
No,
See what
I'm going to show you how to get the other one. I'm going to show you how to get the other one. It's just that I think somebody had stopped me. It could be you too, and we stopped to just sort out something. So I'm going to show you the other one.
So where the 2 pi n come from?
Don't worry about don't worry about that part. You know what the cursor is? Look at the cursor there. 135.
All right.
Yeah, man. 135. All right. So I remember asking the question, and Tani, same one answer me. I said, where is cosine negative? And Tani says, sir, the second quadrant and the third quadrant. All right, very good. Lord. I didn't want to do this because it's going to mess up my stuff, but sorry, let me just do it. Because if it makes life easier. Oh, great. I'm going to draw something, Tantan, and the others to show you how we can get how you'll know the 5 pi by 4, because the truth is, unless you have the diagram in front of you, before you'll know that the 135 is going to be corresponding to the other one. Watch me. C-A-S-T. In here, so it's going to be, Lord Jesus, I wonder if I remember, 180 degrees minus theta. This is 180 degrees plus theta. And this is 360 degrees minus theta. And the angles are acute up there. All right. So the first angle was, so we asked the question. We asked the question, where is, let me just come here. So, where is cosine negative? And we say cosine is going to be negative in the second quadrant and the third quadrant. All right. Ouch. So we get our angle to be 135. So we got our angle straight up when we do this calculation to be 135. We know 135 lies within this quadrant. Talk truth.
Yes, sir.
Good. So we need to, so we're not going to do nothing else with that 1 year because we know that the 135 already lies within this quadrant somewhere. Somewhere right there. So 135 degrees. Where else is tan is cosine negative? In the
Third quadrant.
so it's going to be 180 degrees plus 135 degrees. What is 180 degrees plus 135 degrees?
350.
What? (300) to 315 degrees. Hold on there. 180. Hold on, there's something's not working out right here. Hold on.
Sir, I think it's supposed to be 225.
It's supposed to be 225, yeah. It's supposed to be 225. Supposed to be 225. Supposed to be 225.
Sir, I think it's supposed to add 45.
You mind, it would have to be that, but I'm going to tell you I'm going to tell you something is look at it, find out that and that, and 100 that, and this is 135. The root 2 over that got to be 135. The root 2, the negative root over to be 135. So 135 and coming. It's 135. And 3 times 130 was equals to 135. 180 plus 45 is all right. I'm coming to this one. I'm coming to this one. This one I'm missing something right here. I'm missing something right here. Right here though is this angle coming down here will be our 225 because I'm adding the reference angle for cosine is my x-axis as we indicated. So the reference angle here is going to be for 135 is going to be to the x-axis here. From this angle to this angle here is going to be my 0.7, and this 225 is also going to be that reference angle, and that's CAST, that's 180 minus 180 minus 180 plus. All right, soon come. SOON, so I'm not using, let me just use the other thing. I'm coming back to this one before class ends. Coming back to that one. Cassie, you were asking about the 2 pi by n. What I was saying to you is the 2 pi by n here is because it asks for all answers. It asks for all. Let me just put that right there. It asks for all answers. And the all answers now I have to put in this value to show you that if it can go multiple times around the let me just stop this. It goes multiple times around. So when as many times as I want to go around, that 2 pi by n. The 2 pi is a complete revolution, and n is representing the number of times that I'm going to go around the circumference of the circle. All right. So 2 pi by n. If they were to ask you find all the angles, you can't just find 2 because you have to go around again and come back to this one. So it's going to be 360 plus 135. So 300, check for me. 300, 360 plus 135. Find the cosine of that and tell me what you get. 360. The cosine of 360 plus 135 is what?
Negative root over 2.
Very good. Negative root over 2. Because I would have gone one more revolution around. So what if I got 2 revolutions? 2 revolutions is going to be 360 and 360. That's 720. 720 plus 135, that's 855. So find cosine of 855 and tell me what you get.
Negative root 2 over 2.
Negative 2 over 2.
Are you following the point I'm making? Are you following the point I'm making? So what I'm saying to you is this 2 pi by n is telling you the number of revolutions that you're going, and the 2 pi is telling me that it's a complete revolution. So if I'm making 6 revolutions, it's going to be 2 pi by 6. So it's going to be 360 times pi. So 360 times 6 is going to be 2,160, and 2,160 plus 135 is going to give me 2295. Now the cosine of 2295 is also negative root 2 over 2. If you don't believe me, check it. Cosine of 2295 is going to also be right. So this 2 pi by n, Kessie and others, is just telling the number of revolutions that you would have gone around. It is just indicating the number of revolutions that you are going around. All right, and the number of revolutions is telling you that as n is telling you the number of times you go around. So if they decide they want to go 1,000,000 times, it's going to be 1,000,000 times 360 plus 135. You're still going to get the same answer right here. So this 2 pi by n is just telling you the number of revolutions that you're going around. All right, let's just look at number 2, the second method before I come back to this one. So from here, with the negative root 2 over 2, you can just go ahead and look at the unit circle to determine the angle in radians. Right, so negative root 2 over 2 is going to be negative root 2 over 2 cosine is right here. You can just look at the angle in radians. Bam, bam. When I say look at the angle in radians, you will need to know the angle in radians to say that it's going to be 3 pi by 4 and 5 pi by 4. And 3 pi by 4, 5 pi by 4, because it asks us to find all the angles, as I said a while ago, all the angles, I must include this 2 pi by n. Just include 2 pi by n to indicate all the angles. If they don't answer for all the angles, don't include 2 pi by n. If they say to you that between 0 and 2 pi, just give them an angle between 0 and 2 pi. You know what I should have said to you? Watch me. If them said to you right here, so what if they had said to you? Let me generate that question. Copy. What if in this question they ask us only for 2 pi, for pi? They said they only want your answer for pi. No, hold on. Is this 180? Where were we? This was pi by 6, that's 30. Okay, the angle will still be the angle will still be the 3 pi by 4 because it goes up to pi. But what did I ask you for pi by 2? That's the point I was trying to make. Pi by 2. Pi by 2. Pi by 2. So what did they have said to you? You want the angle between 0 and pi by 2. You must know that pi by 2 is going to be equal to 90 degrees. So all the man them wanted to do is just find the angle from here so to here. So not 2 pi as in the first example that we did. If they asked us 0 to pi, it would have taken into consideration both angles to be pi by 6 and pi by 6, right? But if they said to you between 0 and pi by 2, so pi by 2 right here, so 0 and pi by 2, it means that between 0 and 90 degrees, and only this angle alone falls between 0 and 90 degrees, because this other angle here, 150 degrees, is going to be more than 90 degrees, so you can't use this angle. Am I clear right there?
Yes, sir.
So you have to, so the conditions are important for you to look at. So in this case, when you have pi by 6 and 5 pi by 6 for the answers up here, in this question, because the conditions are different, your answer, one of the answers won't be necessary. It is an MPOR. It is important to note the conditions given for the question. It is important to note the conditions given for the question. Writing your final answer. Very important. All right. Let me just, I don't want to use this thing here. Sure. All right. So come back to you. All right. So that's what will happen in a case such as this. All right. Now let me show you another convention. Coming back to that one, but let me show you another convention. We're going to be solving for x in the equation. We're solving for x in the equation. 2 sine x plus the root of 3 is equal to 0. Where 0 is, or you write something here, so 0 and 2 pi, and 1 they write us about the one here. Anybody know all this, what this means? Nobody?
X is more than 0, but less than 2 pi.
Very good. So it is, so the 2 pi is not included, but the 0 is included. Right? So the 2 pi is not included. The 2 pi is not included, but the 0 is included. So when you see the square bracket here, suggesting that the 0 is included, but when you see, so this is closed, but this is open. Open, it means that we can't go as far as 2 pi. So you have to know that, you have to know the conditions. Here is 0 and 2 pi, a complete revolution. This is not a complete revolution here. This one is just a piece of a revolution, just a quarter of a revolution rather, right? Because this is 90 degrees, right? And here now them telling you, say, this piece is, yes, is between 0 and 2 pi, but 0 is included, but 2 pi is not included. All right, so let us investigate this. We investigate this and we take a little break and then we'll come back. So 2 sine x plus the root of 3 equals 0. Remember, we're trying to isolate the x, meaning we want to get the x alone on one side. Or I think I use a different method to do this one, but never mind. So we want to get the x alone on one side, right? So this here, this positive root of 3, I'm going to subtract it from both sides. So when I subtract the root of 3 from both sides, I'm going to have 2 sine is going to be equals to the root of, is the negative root of 3. It's going to be equals to negative root of 3. Let me just put a space here so you can see the negative sign. So all I'm doing is subtracting the root of 3 from both sides to get rid of this. And then I'm going to have negative the root of 3. All right. And then now, in order to get this 2 from the sine x, I'm going to divide both sides by 2. Why are you dividing, sir? Because this 2 is being multiplied by the sine of x. And the opposite of multiplication is going to be division. So I'm dividing both sides by 2. So I'm going to end up with sine of x is equals to negative the root of 2 over 2. And that's what I'm going to have here. Let me show you another example, another method of doing the question. We know our triangle, our 60, 30, 90 triangle. We know that the 90 degrees points in the direction of the hypotenuse, which is going to be 2. We know that the 30 is going to correspond to the 1 because the smallest angle to the smallest value, and the 60 is going to correspond to the root of 3. Now, it says from the above triangle, we can see that the reference angle is 60 degrees. We can see that the reference angle is 60 degrees because it is negative. Because it is negative, we can safely say that it is in the 3rd and the 4th quadrants. Oh. Anybody agree that it's in the third and fourth quadrant because of this negative sign? Where is sign negative?
Third and fourth quadrant.
Yeah, man. Sine is negative in the third and fourth quadrants, right? So from here, we can look at this, the unit circle, determine the angles, all right? So sine is what? Opposite over
Hypotenuse.
hypotenuse. So if you look at this reference angle here as 60, the opposite side to 60 is going to be the root of 3. The opposite side to 60 is going to be the root of 3 because this one is going to be adjacent and the hypotenuse is 2. So that's why I said to you that the reference angle is 60 degrees. Let me say it again. Somebody didn't see that. Sir, you read a while ago that from the above triangle, we can see that the reference angle is 60 degrees. Sir, how did you know that? Because based on what it is that we based on what we did in translating this equation from 2 up here, so 2 sine x plus the root of 3 equals 0, we ended up now with sine of x is equal to negative the root of 3 over 2. But sir, a while ago you teach us to find the inverse of on both sides. Yes, ma'am. That's another example. So I'm showing you multiple ways that you can double check your answer to make sure that you are on the right track. All right. So I am finding this is sine x is equal to negative root 3 over 2. Now, I know we don't have a negative signs right here, so we do have a negative signs right here. The mere fact that you know that this is negative, it is telling you that sine is negative. It is telling you that your answer lies in the third quadrant and in the fourth quadrant. Sir, how do you know? Because CAST, sine is positive in first and second. Sine is positive in the first and second quadrant. Sine is negative in the third and fourth quadrant. So the mere fact that that angle is a negative angle suggests to us that we can safely say that this is in the third and fourth quadrant. So then how you know that reference angle is 60? Because sine is opposite over hypotenuse. All right. So we can't use 30 because the opposite side to 30 is 1 and up here says not 1. So if this is this, that means it has to be this which is opposite to it. So it's going to be the opposite side over the hypotenuse, which is root 3 over 2. And we know that it's negative, so it's going to be in the third and the fourth quadrant. All right. So tell me now what you get for sine inverse of negative root 3 over 2.
Negative 60.
Negative 60.
Negative 60. Very good. Negative 60. All right. And this is very good for you to tell me the negative 60. I mean, very quickly too.
Sir, I can take a picture and send you an WhatsApp of what I wrote.
All right. You want to take a picture and what?
Send you. I will send you what I wrote.
What you wrote? Oh yeah. You can do that. But just don't read yet. Let me just finish explaining this one here. So, Lord have mercy. What is saying? What again? You got negative 60. I was doing a mental calculation a while ago. You got negative 60, right?
Yes, sir.
Okay. So let us go back to what it is that we wrote right here. So, so we are saying that the answer is going to lie within the third quadrant and the fourth quadrant. So we're saying negative 60, but we're not going to write the negative sign because the negative sign is just telling us the location of the angle. So the negative is telling us that it's in this quadrant and this quadrant. So if I add 180 degrees to 60, what I get?
240.
240.
240. All right. So just remember that 240. All right. And if I subtract 60, because this angle here is going to be 360 minus 60, I can't have greater than 360 in the revolution. So 360 minus 60 is 300, don't?
Yes, sir.
Yes, sir.
So I'm saying to you that my reference angles will be 240 degrees and 300. 240 degrees and 300. And see here, negative root 3 over 2. So you see what I did with, well, I don't know if it will work out with this one. I need to look back at the first one I just did. I'm missing something, but it worked out for this one here, and it should work out for all of them. Where am I? No, I'm at this one, right? So this is 200. Oh Lord, where was I? Right. So when you evaluate this, if we were to use this, find the inverse of sine. The sine inverse of negative root 3 over 2 is going to be negative 60. And we're using the negative sign is telling us the position. Just like when you find a negative acceleration means that you're decelerating. So the negative 60 is telling us that that value of sine is going to be in the third quadrant and also the fourth quadrant, because that's where sine is negative. Now in the third quadrant, I'm going to have 180 degrees plus the angle, the reference angle, right? No, I'm saying to you, it's not going to be negative 60. Negative 60 is not the reference angle. The reference angle is 60. The negative sign is telling me that it's in the third quadrant and the fourth quadrant, telling me where sine is negative. So when I add 180 degrees to, see here, 180 degrees plus the angle, 180 degrees plus the angle at 60 is going to give me 240 degrees. And when I subtract 60 degrees from 360, I'm going to get 300. So my angle is going to be 240 degrees and 300. And when I look at it, I will see here that my sine is going to be negative root 3 over 2, as I suspected. What that is going to be? That is going to be 4 pi by 3 and 5 pi by 3. 4 pi by 3 and 5 pi by 3. So that explains why I have that example, the answer as 4 pi by 3 and 5 pi by 3. Look at it and tell me if you see where I'm going, what it is that I have done in order to get my answer there. Right here, I was saying to you that you can reference the feature from here, look at the unit circle to determine the angle in radians. That's what I'm saying to you. I'm saying when you get the negative root 3 over 2, you're going to look at the unit circle, negative root 3 over 2. See here, negative root 3 over 2, you can look at the unit circle and we know it's 4 pi by 3, and you can look at the unit circle and we know it's 5 pi by 3. But when you're in an exam, I don't know what the unit circle, you don't have a picture of the unit circle to just read off and say 4 pi by 3, sir, and because in any event, remember that that the reference angle is going to be in the third quadrant and the fourth quadrant. So there's no need for you to be looking up here. You're only going to be looking down here, the third quadrant and in the fourth quadrant. So this is where you're going to be looking in order to find your angle. And if this piece here, the only negative root 3 over 2 for sine, remember sine is reference point to the y-axis. So it's going to be this reference point to the y-axis and this reference point to the y-axis. So when you look at the unit circle, this is what you will get. But your question now is, sir, if I don't have the unit circle in front of me, how else can I know what to do in order to calculate it to get the correct answer? Which is exactly what I showed you. So you know that sine is negative in the third and fourth quadrant. And you know that root 3 over 2 is 60. But sir, we have negative root 3 over 2. Yes, the negative sign is only telling you the placement of the angle, which quadrant or quadrants the angle lies in, right? And we know that because the angle here is negative, telling us that it lies in the third quadrant and the fourth quadrant. Now, the reference angle that we're talking about is a 60-degree angle. That's the angle we're talking about, a 60-degree angle. Okay, sir, got you. In the third quadrant, it is going to be 180 degrees plus 60 degrees. That means it's going to be 240 degrees. And in the fourth quadrant, it's going to be 360 degrees minus 60 degrees. So it's going to end up with 360 minus 60 is going to be 300 degrees. So what it is that you're working with is 240 degrees and 300 degrees. Right up here. So 240 degrees and 300 degrees. And when you look back at it, you can see the negative root 3 over 2 and the negative root 3 over 2. No, 240 degrees is going to be 4 pi by 3. And the 300 is going to be 5 pi by 3. So, Kessie, it comes back to what it is that you're asking me now. In terms of knowing the inside of something, yes, you have to go know it. Because if when you get you're 240 degrees. You're 240 degrees. And in order to convert your 240, matter of fact, do this for me. Do this thing quickly for me, please. Put in your calculators 240. Just clear your calculators and just put in 240. Don't touch nothing else after putting 240. And then press the ABC now and put 180. And tell me what you get.
1/1/3, which is
Press second function ABC and it gives us an improper fraction. Press second function ABC and what it gives you.
so will that be 4/3?
It will be 4/3, right? So that explains this 4. You just put the pi beside it. 4 pi by 3. We got 300. Divide 300 for me. 300 divided by 180. And tell me what you get.
5/3. 5/3.
5 pi by 3.
5/3.
You see where I'm going? So I am showing you so many different ways that you can just go ahead and calculate your angles in degrees. You know what it is that you're doing. You're converting degrees to radians. You divide by 180. I told you this from the first class, right? So you just divide it by that. The fraction that you get, you just each up the pi in it. You can say 5/3 pi. 4/3 pi. They mostly be right. And if you want, you can say 5 pi by 3, or you can say 5/3 pi. Same difference. Same difference. So that's how you go ahead and do that level of calculation. All right, I did promise you that I'm going to take a break. My throat is very dry and I need to go refresh myself. We're going to come back and we're going to work on a couple more examples, and then I'm going to generate some more questions so we can work it out. And then we have one final thing, no, two final things to look at. It just says to us that to identify the graphs of sine, cosine, and tangent functions. So it just said we need to identify it. It never said we must do anything to it, just identify it. And I have those graphs to identify. The last piece says solve problems involving graphs of trigonometric functions. And I have one question here for you. Try generating another question, and I was asleep and it just never worked out so well. So that's why I highlighted. But take a little break. I'll give you about a 10 minutes break and then we'll come back and wrap up. All right? I'm muting. Okay, guys, are we together again?
Yes, sir.
All right.
Yes, sir.
Yes, sir.
Let me ask you a question. Only ever laugh upon yourself yet? Anybody? Just stop. We're just having a candid conversation now. Anybody ever laugh upon themselves yet?
Every day,
Yes,
multiple times per
every
day.
day.
Yeah.
All the time.
Listen to me.
It's a hobby.
Listen to me. If something happened to me and wanna laugh after me, I'm not going to feel no way because guess what? You see, before you start laugh, me go laugh. I had a grandiose laugh at myself a while ago because I'm there saying, why is this thing not working out? Why is this thing not working out? Oh boy. Anyhow, do me a favor. Do me a favor. I am writing down right. Evaluate pi by 4 for me, please, and tell me what you get. Pi by 4 gives you what number? What value?
3.9.
3.9. All right. 3.9. So I am sitting here and I look at myself and I said, Jesus God. I mean, as I look at it with another eye, I recognize where I would have gone wrong. Am I allowed to to um to write 135 degrees?
So what do you mean?
All right. So what I'm saying to you is I am getting 135 degrees. The root, the cosine inverse of root 2 over 2 is going to be 135 degrees. All right. And I'm saying to you, this is my whole setup. We know that the angle is negative. We know the angle is negative. If the angle is negative, we know which quadrant the angle falls in. It can't be the first quadrant. It can't be the second quadrant. It must be the third quadrant and the fourth quadrant. In the first quadrant, the angles are as is. In the second quadrant, it's going to be 180 degrees minus theta. In the third quadrant, it's going to be 180 degrees plus theta. And in the fourth quadrant, it's going to be 360 degrees minus theta. So we know our reference angle. Our reference angle is 135. You notice we never say negative 135. So it's going to be 180 plus 135. What is 180 plus 135?
315.
315. Yeah, man. Hold on to 315 for me here. Hold on to 315 for me. And what is 360 minus 135?
225.
Yeah, man. So let us go back up to where we are now. The point is I made a mistake with the question. So we're at 315 and 225. See here, 225 and 315. There is no way I can be at 225 and it corresponding to 300 because 225 with my, where am I? Cosine or sine? I'm at sine, right? So sine, the angle. Yeah, it would have to be sine. There's no way I can be at 225 and draw my reference angle to come here. That is going to be matching with 300. The only thing can match which is 315. So we just calculated a while ago. 180 plus 135 is 315, and 360 minus 135 is 225. So the angles in question that we're talking about will be 315 and 225. Now, 225 divided by 180 equals
1.25.
Give me as improper, please.
Sorry, people.
1 and 1 over
5
4.
over
So
4.
5 over 4.
5 over 4. So you're going to be, I'm coming to you, whoever asking that question. So you're going to be 5 pi by 4. So the answer is supposed to be pi, no, 5 pi by 4. So this answer is correct. Then do me a favor now. Divide 315 by 180 for me, please.
Seven over 4.
Is what I have
Four.
right, is what I have right here, so?
Yes, sir.
I have three. Everybody see what I have. Hold on. Everybody see what I have right here. I
Yes,
don't know what
sir.
I don't know what sir was doing when he was setting up the notes for you. I put 3 pi by 4, and that's why it wasn't working out. That's why it wasn't working out. It's supposed to be 7 pi by 4. I have 3 pi by 4. You know, I'm happy that this happens because I want to show you that I'm also human. Some of them sit down and say, yeah, bug I didn't get the question wrong. Or good feel. Yeah, no problem. That's fine. At least I see the solution. All right, hold on there now. Hold on there now. So we need to double check. So we're getting 5 pi by 4 and 7 pi by 4. 5 pi by 4 is right here, and 7 pi by 4 is right here. And we're talking about negative root 2 over 2 see here, negative root 2 over 2 see here, negative root 2 over 2, and see here, 5 pi by 4 is 225, 7 pi by 4 is 315. So it does work out using the method that I have right here. So just remember, here is going to be 180 minus, 180 plus, and 360 minus. Kessie, were you coming in with a question?
No, sir.
Oh. Somebody was saying, sir, when I was trying to finish up the explanation. So I can take off my soon come businesses. I wonder what keep. And this is something that I've been using from John was our boy. So my question is, would it be 130? Tani, I was asking, you know, would it be 135 right here then?
Yes. Yes. Yes, sir.
But remember, so we can add it to 180, you know, that's what I was asking the question. So the angle itself can't, well.
Sir, but that's what I was asking you when I asked you initially, sir. I was asking you if the angle is supposed to correspond. So if you get the, well, before you had 3 pi over 6, I think. I was asking if the other one was supposed to correspond, but you stopped me to explain something else.
Okay, all right, I apologize. Go ahead and ask now.
Sorry, I already fixed it.
Okay, all right then, cool. All right, bless up, bless up, bless up, bless up, bless up. All right, are we okay, all of us together? Are we feeling a little ish, all right-ish? Is there anybody in the class that is not following what it is that we are doing? And a little bit-ish understanding?
Yes,
Sir,
sir.
I understand 80% of the way, so that's good, I think.
That's great. No, man, that's great. When you do the other piece now, you should get the other 20%. But if when you do it, you don't get it, we'll come back to it. Sorry, who was that? Was it John Mark? Who was that coming in? Was it you, John Mark?
Yes, sir. Yes, sir. I said I understand a little bit.
Very good. All right. Now, the importance is for us to see if we can maximize the understanding in class, so that when we get out there on our own, we will be able to use what it is that we have to move on. All right. I have a question here. Solve for x in the equation 3 tan x plus the root of 3 equals 0, and the angle is between 0 and 200. Sorry, and 2 pi. Sir, this is what I don't understand with teachers, you know. All the examples you do so far, sir, is sine and cosine. And then you will ask us to try something with tangent. Okay, fair enough. I used to complain myself when I was a student. The question is, use the information. Let us see if we can translate. Let's see if we can translate the knowledge. So use the information that we've been using with cosine and sine, and let me see how many of you can come up with this answer. So I'm going to give you 5 minutes to try this on your own for me. Don't worry about it. I'll come in to rescue those of you who may be stopped. All right, start please. We're not even talking program. All right, since we're not talking to, let me talk to him. Can we use a unit circle for this one?
No, sir. No,
Right.
sir.
No, sir.
Right.
Yes, I cannot find it. Is it too
And
negative?
change
You can't.
it on the unit, sir.
Okay, all right. All right, I hear you. Let's go. Let's go. So I'm going to subtract the root of 3 from both sides. Remember, I'm undoing. Just follow, sir, and you should be good to go. I am undoing. I want to isolate my x. So I want only x to be on one side of the equation. So all I'm doing is enough to isolate my x. First thing I'm going to do is to subtract 3 from both sides. So I'm going to have 3 tan x is equal to the negative of root 3. And then I'm going to divide both sides by 3. So I'm going to have the negative of root 3 over 3. All right, the negative of root 3 over 3. And then I'm going to multiply by tan inverse to both sides. So this tan is going to go, so I'm just going to be left with x, and then my tan inverse comes right here. So I'm going to have tan inverse of negative root 3 over 3. Did you get negative? Do you get negative 30 for your answer?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. Negative 30. So what is that negative 30 telling us now? That tangent is oh Lord, I just had a mind is negative 30. So tangent is negative where?
First
So in
and
the
third
second,
quadrant.
and then fourth.
In
In the
the
second and last
first,
quadrant.
In the second and the fourth quadrant, don't.
Yes, sir.
This is 180 minus. So you're going to be 180 minus 30, which is 150, don't.
Yes, sir.
And 360 minus 30, which is 330. So I should get 153.30. So
Yes, sir.
I have 153.30. But in radians, remember, we need to calculate our answer if we're definitely using this method in degrees, and then we'll convert from our degrees now to our radians. So we need to convert 150 degrees to radians. Is 150 divided by 180, and I'm going to get that fraction as 5/6. 150 ABC 180, second function ABC again, and you should get 5 over 6. So it's going to be 5 by 6 pi. See it here, so. Then 330 divided by 180 is going to be equal to the same 1.83. I'm going to get 11 over 6. So it's going to be 11/6 pi, or 11 pi by 6. And this corresponds to this, and this corresponds to that. And that's our answer. Those are our answers. Anybody got those as their answers?
Sir.
Yes, sir. Yes,
Very
sir.
nice.
sir, did you say that
sir.
tan is positive in the third quadrant?
No, tan is positive. Maybe it's negative. Tan is positive. Yeah. Tan is positive in the third quadrant. Come on. So this is 180 plus. So this is going to be 180 minus. Tan is negative here and here. Come on. So tan is positive in the first and third quadrant, but tan is negative in the second quadrant and the fourth quadrant.
Also, so you need to look for where it is negative, because it's negative 30.
Somebody understands something tonight. So remember now, this negative sign is telling us where tan is. Telling us what tan is.
Where the which quadrant it is in.
Very good. Very good. Very good. Very good. All right. I have like about 10 minutes left. Let me just run through this piece here. Of course, I'll go back to it, but I just want to run through it. This piece says to identify the graphs of sine. Okay, so it's a graph of the sine, cosine, and tangent functions. So, as I said to you last class, the cosine graph is starting at my 1, the cosine of 0. Remember, this is cosine and sine, and this is 1, 0. So the cosine of 0, this 0 degrees is going to be 1. The cosine of 0 degrees is going to be 1. All right, the cosine of 0 degrees is 1. The cosine of 0 degrees is 0 here, so anywhere along this is 0 is 1. So the cosine starts up here, so, and it comes down and it goes down to pi, which is going to be -1. Pi, see here, pi is -1. Remember, cosine is written first and then sine is written after. So 0 for cosine is +1, pi for cosine is -1. So pi is going to be -1. And then when it goes up, it's going to go back up. It maximizes again at 1, and we're going to come back down and minimize at -1. And each of these is called a period. So this is one period, and this is another period. But you'll see more about the periods as I move into the other example. I just want you to be able to identify the cosine graph. So when you look at the cosine graph, remember, the cosine graph starts at 1. 0 corresponds to 1. Now, when I say it starts at 1, this is what I mean. I'm starting at 0. The cosine of 0 is 1. The cosine of 30 is this. The cosine of that, another. The cosine of 90 is 0. The cosine of 180 is -1. All right? So, when you look at the cosine graph, cosine of 90, cosine of 0 is 1. It goes up here. The cosine of 180, see here, pi, which is 180, is going to be -1. The cosine of 90 is 0. Sir, what do you see that? The cosine of 90, pi by 2 is 90, see here, 0. Cosine of 90 is 0. So is the cosine of 270. All right? So is the cosine of 270. See here, 270, it is 0. And cosine of 360 has the same value as cosine of 0. Cosine of 360 has the same value of cosine of 0. So this is one revolution. So from here to here is one revolution. That's one revolution. 90, 180, 270, 360. So the cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180 is -1. Cosine of 270 is 0. Cosine of 360 is 1. All right, so this is what the cosine graph looks like. Let us look at the sine graph. The sine graph looks pretty similar, sir, but the sine graph also go from 1 to -1. Yeah, man. But it is a different phase because the cosine of 0 is the sine of 0 is 0. But sir, remember what here says sine, the last one is sine, teacher. Sine of 0 is 0, but sine of 90 is 1. And sine of 180 is 0, and sine of 270 is going to be -1. So the sine of 0 is 0. So because the sine of 0 is 0, it's going to start here at the crosshairs. And the sine of 90 is 1. The sine of 180 is the same as the sine of 0 because it's on a straight line. And then now this is going to be opposite to this because this is up the north and this is on the south. And then this value here is going to be the same as this value here at 0. 360 and 0 corresponds to the same value. So the sine graph comes around this way. And interestingly, if I were to, I'm not going to tell you. I'm going to see if I can find that video and demonstrate it. I was actually trying to use my software to demonstrate it, but I'm not there yet in terms of fully manipulating that software, but it can do a bit of animation, and I'm going to see if I can work on it for this weekend to do some animations for you in that regard. So if you look closely now, oh dear, you don't know what happened.
Sir,
Yes, please.
I had a question for the last question.
Go ahead.
For the, I understand when you get the 150, but for the 330, I was looking for you to look for the negative square root 3/2.
Negative 3/3. That's what I mean. They said 3/2, but it's 3/3 you mean, right?
Yes, sir.
Right. You remember the question that Tenny asked? You're not looking for negative. The negative is telling you where the quadrant is located, where the angle is located. And tangent with a negative answer is going to be in the second quadrant and in the fourth quadrant. So tangent, A mean all angle. A is going to be cosine, sine, and tangent. S is sine, T is tangent, C is cosine. Where is cosine 30 degrees? Where do I find cosine? Rubbishness. Where do I find tangent of negative 30? Negative? It can't be in this quadrant because all the angles are positive. Tangent can be negative in this quadrant because I just a tangent positive. All the other angles are negative here, away from tangent. All the other angles here, away from sine, is negative. All the angles here, away from cosine, is negative. All the angles up in here for A are positive. So because tangent is a negative 30, it suggests that the angle is right here so, and right here so. And the angle that is up in here so is going to be 180 minus the angle. Why 180 minus the angle, sir? Because we're here. If the angle is up in here so, it's this line, angles on a straight line are to give 180 degrees. Angles on a straight line are to give 180. So I can't have 180 degrees plus right here so, because if I have 180 degrees plus here so, even if it's plus 1, it means that the angle can fall down here so, and that can't be. So the angle has to fall inside here so. I mean, it has to be 180 degrees minus. Right here so it has to be 180 degrees plus. Sir, why? Because if this piece here is 180, when it comes down in here, so it's going to be 180 plus the angle in order to find here so. Then, sir, why is this 360? Because a complete revolution is 360. So it has to be, can't be 360 plus, because if it's 360 plus, it's going to be an angle that is greater than. So it has to be 360 minus. Now, if tangent is negative here and here, it means I'm going to subtract the 30 degrees from here. So it's not a negative 30 per se, no. The negative is telling me that the angle is negative here. The reference angle is 30. Let us use the terminologies. The reference angle is 30. The reference angle is 30, but it is telling me the position of it. And the position of it now is going to be in the second quadrant and the fourth quadrant, because that's where tangent is negative. So here it's going to be 360 minus 30, which is going to be 330. And right here, so it is also negative, it's going to be 180 minus 30, which is going to be 150. And that's how we end up getting our 150 and 330. Tell me if you see that, mommy. A little clearer.
Yes, sir.
All right, nice job. All right, in 2 minutes, let me just show you now together, because the next thing is going to be the tangent, and then that number 4 is just a question. Then come next class, all being where we just play around with some more examples, and then we just say, you know what, we're done with that one, and we'll move on to something else. So the cosine graph and the sine graph, when I put them all together, you know, I can read it off. I can say the sine of 90 is going to be 1, but the cosine of 90 is going to be 0. The sine of 180 is going to be 0, but the cosine of 180 is negative 1. The sine of 270 is going to be negative 1. The sine of 270, cosine of 270 is going to be 0. The sine of 360 is going to be 0, and the cosine of 360 is negative 1. So you look at the graph, and if you really look at it, watch me. if I hold a graph right here, so, and draw it over to here, so, tell me what happened to the graphs.
Intersect.
Them kiss. You can say the word kiss, you know. Kiss is a good word. In math class, that is. Watch me. But yes, intersect is a mathematical term. Right. So we're going to use intersect. So if I hold this graph, I can't hold it. If I hold this graph and I pull it to here, both graphs intersect. So what I can say is that one graph is out of phase to the other graph. So, you know, this is one phase to another phase. So this is one phase of the graph to another phase of the graph. Up here is one phase of the graph to another phase of the graph. Right here says one phase to another phase, one phase on here to another phase, right? And finally, the tangent graph is just asymptotic, you know, to this line here, 270, asymptotic. Means, say, let me start with a positive here. So it means that try finding for me tangent of 90 degrees and tell me what you get.
Math error.
Yes, because it does not exist. So at this 90 degrees, it not exists. So that's why it forms an asymptote to this line here. So it comes this way and goes this way. Not going to get it. But you can find 180, but you can't find 27, but you can find 360. All right. So the graph, so the tangent graph, you can go all the way up. You notice it don't stop at negative, a positive 1 or negative 1. You have 1.5. You can go 3 and 4. You can find. This is why you can't find sine of you know, the value of sine, the sine graph and the cosine graph lies between -1 and 1. The tangent graph, you know, have them boundaries there. It go along, because the only thing it has are these vertical lines, suggesting that it can't go beyond those. All right. I know you may need a little bit more time. Don't worry about it. As per usual, just like I went over the unit graph, the unit circles. Are you feeling a little bit more comfortable now how to apply the unit circles to the questions?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Nice. And very good, Natalie. I hear you loud and clear. Are you feeling a little comfortable now solving a trigonometric equation using the different methods, you know, with using the method that Sir showed you, where, you know, the sine and the cosine, you can use a unit circle for the stuff, but if you're given a question with tangent, best believe so, because the unit circle only have sine and cosine, you can't use it, so you have to still go back to the other method that Sir was teaching you, which is why I say, you know what, let me teach you both methods, so at least you know what happens right across. All right, so don't worry about it. It is it comes with practice. And as I said before, you will see me touch this question again, this topic again, because, you know, I need to do some more questions with you. You know, I want you to go over the unit circles again for me, you know, the degree and the radians, and just feel a little comfortable. You know, see if you can commit it to memory, and see if you can just commit these, you know, little things, you know, like the CAST and the 180 minus theta, the 180 plus the 360 minus. I've given it a reason for it to be 180 minus in the second quadrant. I've given it a reason for it to be 180 plus in the third quadrant. And I've also given it a reason why it is 360 minus in the fourth quadrant. I didn't give you anything for the first quadrant. Oops, actually I did, because I said that all the angles there are acute, lie between 0 and 90 degrees. All the angles in the first quadrant are acute, lie between 0 and 90 degrees. So don't be afraid of the trigonometry. Don't be afraid of the trigonometry, because the trigonometry is here to stay. And on the exam papers, I'm seeing where it give you about 10 marks, you know, for the question or questions that they give you. All right, you've been a good set of students. Have a good night. As soon as the recording is made available, I send it out for you. Have a good night.
Good night,
Bye, sir.
sir.
Same to you.
Bye, sir.
Bye,
All right,
sir.
cool. Yeah, man.